Every single morning, as dawn light filters through frosted window panes and quiet suburban streets begin to stir, an invisible network of intelligence activates directly above our heads. A single American crow perches on a weathered wooden telephone pole, its iridescent black feathers rustling against a cold morning breeze, its dark obsidian eye locked onto a front porch below. To an untrained observer, this bird is simply waiting for discarded food crumbs on a patch of concrete. But neurobiologists and modern cognitive ethologists now understand that this solitary sentinel is executing a complex, real-time assessment of human behavior. It measures the precise gait, posture, and facial features of the person stepping out the front door. It notes the specific angle of a carrying bag, the deliberate speed of footsteps along a gravel driveway, and the exact routine of a daily commute. Within seconds, the sentinel emits a low, rhythmic rattle from its throat, a subtle sound wave traveling across oak canopies, garden fences, and damp asphalt. This is not a random vocalization born of instinct. It is a precise acoustic signal encoding rich contextual information, passing complex data to dozens of listening songbirds and corvids hidden among pine branches across 3 residential blocks. For centuries, classical biology categorized avian vocalizations into simple binary signals, basic mating calls, or primitive distress screeches triggered by immediate survival instincts. That ancient paradigm is now crumbling under the weight of empirical data. Deep inside the avian brain, within a specialized high-level integration center called the Nidapallium Avian Impulse Network, complex auditory signals are processed with staggering speed. Birds do not merely react to their environment, they analyze it, categorize it, and construct shared acoustic maps of human activity. Consider the subtle acoustic architecture of the chickadees warning system. When a small, highly agile raptor, like a sharp-shinned hawk, glides silently beneath the forest canopy, its sudden appearance demands an immediate, nuanced response. The chickadee does not simply scream in panic. Instead, it modulates the precise frequency, duration, and terminal notes of its characteristic call. A large, sluggish predator sitting on a high pine branch generates a low-density call structure, but a fast, lethal threat gliding at ground level triggers a high-frequency, rapid burst of terminal notes, a dynamic linguistic code that instantly informs every listening bird in the tree line of the predator's exact physical scale, speed, and trajectory. This acoustic precision forms a regional dialect, a subtle shift in frequency and syntax that varies from one valley to the next, or even between adjacent urban parks separated by a 4-lane highway. In dense suburban neighborhoods filled with lawnmowers, roaring engines, and glass towers, birds adapt their vocal syntax to breach the wall of human noise. They shift their pitch upward, alter the cadence of their syllables, and deploy localized dialects designed specifically to penetrate concrete corridors and heavy atmospheric pollution. To uncover the true depth of this acoustic intelligence, researchers designed field experiments that seemed modest on the surface, but yielded extraordinary results. In a secluded botanical garden, surrounded by low stone walls and thick ivy, ethologists played controlled audio recordings of local bird vocalizations to wild flocks. But instead of standard alarm calls, they broadcast synthetically altered calls, subtly shifting the silent micropauses between syllables by mere milliseconds. The reaction of the wild birds was immediate and alarming. When presented with standard native calls, the birds maintained their natural foraging posture, occasionally tilting their heads to scan the surrounding foliage. But when the synthetically altered dialect was played, a call containing the wrong microspacing between notes, the entire flock froze instantly. Foraging stopped completely. Every beak pointed toward the sky, every muscle tensed for immediate flight. The birds were not merely listening for familiar pitches, they were decoding the subtle microrhythms of their localized syntax. A single millisecond of silence placed in the wrong position turned a routine informational update into a high-priority anomaly signal. The flock recognized that the syntax was wrong, signifying either an unfamiliar intruder from another territory or a corrupted message that posed a potential threat. This experiment revealed a profound cognitive reality. Birds possess an intrinsic grasp of acoustic structure that rivals primitive human syntax. They process sequential sound patterns through neural pathways remarkably similar to the Broca's area in the human neocortex. They break down continuous sound into discrete structural units, reassembling them to communicate specific environmental changes. As night falls over the suburban canopy, the morning sentinel on the power line shifts its position to a high oak branch overlooking an intersection. The streetlight casts a soft yellow glow across its dark, sleek silhouette. It watches a human walk past a park bench, recording the individual's height, stride, and facial symmetry into its long-term memory. Tomorrow morning, when that same human opens their front door, the sentinel will be waiting, ready to broadcast its findings to a listening world hidden just beyond our perception. To understand how deeply this localized dialect embeds itself within avian culture, researchers at the University of Washington initiated a groundbreaking experiment using hand-carved latex masks. A field researcher wearing a heavy, distorted rubber mask captured and tagged wild crows on a university campus before releasing them unharmed. The physical encounter lasted only minutes, but the cognitive footprint left on the flock was permanent. Whenever the researcher walked across campus wearing that specific grotesque face, every crow in the canopy erupted into furious scolding calls, hovering above the individual's head with flared tail feathers and sharp, heavy beaks pointed downwards. What began as a localized threat response quickly evolved into something far more extraordinary, a multi-generational cognitive legacy. Years after the original trapping event, young crows that had not yet hatched during the initial experiment were observed joining the chorus of scolding calls. When the researchers stepped onto a damp concrete footpath wearing the mask, fledglings with soft brown eyes and pristine wing coverts immediately targeted the individual, emitting the exact high-intensity alarm call learned from their parents. The memory of a single human face had been encoded into their acoustic vocabulary, transmitted culturally across generational lines without a single physical attack ever taking place. This intergenerational transmission of information relies on a profound neurobiological mechanism known as episodic memory recall. Within the avian striatum, a dense collection of neurons processes complex visual landmarks, facial proportions, and specific emotional events. When a parent crow observes a threatening human carrying a long metal rod near a pine needle nest, its brain converts that visual image into a specific acoustic signature. Through repeated exposure and synchronized alarm vocalizations, the offspring associate that specific acoustic template with danger. They do not merely learn to fear a generic human silhouette. They memorize the specific facial geometry of an enemy, storing it within a collective mental archive that spans across decades. This cultural archive is not limited to threats. In urban habitats where food sources are scattered across sprawling asphalt parking lots and stainless steel dumpster enclosures, corvids construct intricate acoustic networks to share resource availability. A glossy raven perched on a rusted chain-link fence overlooking a fish processing plant does not simply consume its fill in silence. It executes a series of low-frequency throat clicks and sharp head tilts, inviting specific family members while actively excluding non-kin rivals from adjacent territories. The acoustic signal contains subtle pitch modulations that convey the exact density and freshness of the food source, allowing distant birds navigating heavy fog to calculate whether the energy cost of flight is worth the reward. This sophisticated communication network operates in parallel with human civilization, creating a hidden layer of intelligence embedded within our city streets. As we stride past weathered park benches, iron railings, and concrete overpasses, we are constantly being evaluated, cataloged, and discussed in a language we have barely begun to comprehend. A raven tracking a delivery truck along an avenue notices the exact time the engine cuts out, the metallic clash of the rear door sliding open, and the scent of perishable cargo. With a swift snap of its black bill and a precise wing adjustment, it broadcasts this operational timeline to an entire urban roost hidden high above in the steel girders of a suspension bridge. The evolutionary implications of this hidden language shatter long-held assumptions about animal cognition. For decades, human exceptionalism dictated that symbolic communication syntax, and long-term historical memory were unique traits of the mammalian neocortex. Yet birds whose evolutionary lineage diverged from mammals over 300 million years ago have constructed an equally sophisticated cognitive apparatus using an entirely different neurological architecture. Their smooth, densely packed brain structures achieve processing speeds that rival mammalian cortexes, enabling them to decipher microrhythms of sound and subtle visual cues faster than any human observer could ever track with the naked eye. When you step outside tomorrow morning into the cool morning air, listen carefully to the chorus echoing through the damp suburban canopy. That sharp call echoing from a high cedar branch is not a random burst of nature soundtrack. It is a precise tactical report, a live broadcast detailing your presence, your trajectory, and your past interactions with the wild world around you. We are not isolated observers staring at nature from behind glass windows. We are subjects being actively studied, recorded, and translated by an ancient, hyper-attuned intelligence operating in the trees right above our heads. The hidden dialects of birds are a living mirror reflecting human behavior, an acoustic surveillance system that has recorded our daily routines for millennia. As cities continue to expand and wild landscapes dissolve into concrete and wire, these resilient avian communicators adapt their syntax, refine their dialects, and pass their knowledge down to the next generation. The sky above us is not empty space. It is a dense tapestry of flowing information, an endless conversation between brilliant mind units that have mastered the art of survival in a world reshaped by human hands.